this video, we're going to talk about one final method for solving a quadratic equation. It's called completing the square. You'll see why in a second. Any of these methods are useful for solving a quadratic, some more than others. Basically, completing the square is going to kind of go back to square root method. Sometimes this didn't work before. Completing the square is a way to make it always work, basically. For example, look at these two equations here. This one I could solve with square root method because it only has the one x. This one I could not solve with square root method because I couldn't get both of those x's by themselves. I have to get x by itself. This one I would just add 7, square root, and then subtract 3, and I would have x by itself. Fun fact, these are the same equation. In fact, you can see it if I multiply this out, x plus 3 times x plus 3, because that's what squared means, minus 7 distributes, x times x is x squared, and 3x, and then 3x, and then plus 9 minus 7, which is x squared, 3 plus 3 is 6x, 9 minus 7 is 2, and look, they're the same. This one is, okay, let's start with this. This is what we call standard form, just because it's all just kind of multiplied out. This is something we call vertex form, and we'll talk more about this later, but these are both on your formula sheet. Again, if it's all multiplied out, it's called standard form. If it looks like this, where it's like x plus or minus something squared, this is vertex form. This you can solve with square root method, this you can't. So basically what we're going to talk about today is how to get from something like this to something like this. Basically you're going to want to have something with x in it squared. 1x rather than 2 x's. So to do this, we're going to need something called a perfect square trinomial. Perfect square means it square roots evenly. Trinomial means it has 3 terms. So here's what I mean by this. Take a second and multiply these out. So pause the video and try that on your own. Try to multiply these out. So hopefully you've paused the video and you've tried these. Notice this one becomes x squared plus 2x plus another 2x, and then 2 times 2 is 4. So x squared, 2 plus 2 is 4x plus 4. This one becomes x squared minus 3x minus another 3x plus 9, because negative 3 times negative 3 is positive 9. So that becomes x squared minus 6x plus 9. This one becomes x squared, I'm going to skip here, x squared plus 20x plus 100. Alright, so let's see if you can draw some conclusions here. Take a look at the expanded version versus the original. Like, what do you notice between like 9 and 6 and that 3? Or between 20 and 100 versus that 10? Sorry, my board's spacing out. And then see if you can use that same pattern to fill in this blank. 36 and 12, what do you think would go here? So the pattern you probably are noticing is whatever this number on the end is, it's the squared version of this. 10 squared is 100. Negative 3 squared is 9. 2 squared is 4. Also, the middle number is always double this because we end up having 10x and another 10x, which is 20x. Or negative 3x and another negative 3x, which is negative 6x. So the number that goes here should be the square root of this or half of this, which in this case would be 6, and in this case would be negative 4, because half of negative 8 is negative 4. And the square root of 16 could be positive 4 or negative 4. Okay, if you forget this little pattern, the good news is you can always just use rainbow method, like what multiplies to give you 16 and adds to give you negative 8? So what multiplies to give you 16 and adds to give you negative 8? That would be negative 4 and negative 4. So you would fill those into your factors, negative 4 and negative 4, which if I have two of them, that's the same thing as x minus 4 squared. So really, this is just a shortcut for factoring when you have a perfect square, as in square roots evenly, trinomial, 3 terms. This is going to be helpful because, remember, I want to take something that looks like this and turn it into something that looks like this. If I'm trying to go standard to vertex form, that's going to be helpful. So basically what you're going to try to do is turn your equation into a perfect square trinomial. Something where when you square root it or cut this in half, you get the same thing. It's actually not too crazy. Let's start with trying to figure out how to create these perfect square trinomials. For example, if I had x squared plus 10x plus something, what would I want for that constant to make this a perfect square trinomial? How could I make it like these? Where like, basically, how did I get from 12 to 36? Well, you notice I cut 12 in half to get here, and then 6 squared is how we got 36. Same thing here, like you cut 20 in half to get 10, and then 10 squared is 100. So basically you're taking this middle number, cutting it in half, and squaring it to get that number there. That is a formula that we write out. B over 2 squared. You take the b value, in this case 10, you cut it in half, and then you square it. So in this case, 10 cut in half would be 5, and then 5 squared is 25. So that's what I'm going to add in right here to make this a perfect square trinomial. You'll see why this is helpful in a second. This formula is not on your formula sheet. You're going to have to actually memorize this one, unfortunately. But you always take the middle term, which we call b, like a, b, c, cut it in half, and then square it. And that's what your new constant is going to be. Let's try another one. On this one, the b is negative 2. I'll cut it in half, and then square it. Negative 2 over 2 is negative 1. And negative 1 squared, negative 1 times negative 1 is positive 1. So that would be the number I'd add on to the end of this one. Again, just to make this generic, if it was like x squared plus bx, you would do b over 2 and then squared. All right, so that's going to help us solve these equations. So to complete the square, you're going to do what we just did. You're going to take the b value, divide it by 2, square it, and turn it into a perfect square trinomial. The problem is this number is in the way. 17 is not what I want. So the first thing I'm going to do is actually just get rid of it. And by get rid of it, I mean move it to the other side of the equation at least. So that leaves us with x squared plus 20x equals negative 17. Since I did that to both sides, I just moved it out of the way. And what I'm going to do now is add in a new constant. Just like we just did, I want that constant to make this a perfect square trinomial. Something that will turn into x plus or minus something squared. The way you do that, remember, is you take the b value, b is 20, and you're going to do b over 2 squared. So in this case, 20 cut in half, which is 10, and then squared. So 10 squared, which is 100. I'm going to add that in right here. And now this is a perfect square trinomial. It will factor very nicely. The problem is I can't just magically add 100. That just made this side weight heavier. I need to keep it balanced by also adding 100 to this side. And now it's a legal move. Okay, let's simplify this real quick. 100 minus 17 would be 83. So we'll just leave that be for now. The important part is this. The reason I picked 100 is because this is going to factor very nicely. If you remember the shortcut from a few slides ago, basically you cut this number in half, it's 10. Or square root of this, also 10. But if you forget that shortcut, just use a rainbow method. 1 times 100, so like what times what gives you 100, and oh no, and adds to be 20. They're always going to be the same. Excuse me. So that would be 10 and 10. So this factors into x plus 10 and x plus 10, which is the same thing as x plus 10 squared. Still equals 83. And I am so close now. Notice, I have completed the square, which is I turned this into something squared. I completed the square. Actually, this process right here is completing the square. You fill in a number to make it square properly. So I've finished the completing the square part, but now I still want to solve for x by using the square root method. Square root method is like take the square root, solve for x, get x by itself. We use a different color here. So to get rid of the squared, just square root, both sides. Don't forget plus and minus square root of 83. So that cancels out with the squared, leaving just x plus 10. This does not square root evenly, and it doesn't break down at all. It doesn't divide evenly by 4 or 9 or 16 or 25 or any of those. So I'm just going to leave it plus or minus square root of 83. All right, and then to get x by itself, just subtract it. So these don't combine because that's under the radical and that's not. You can put minus 10 on the end. You could put minus 10 in the front. It doesn't matter. But my final answer, I'm going to put it in the front, is negative 10 plus or minus square root of 83. That will give you a decimal, 2 different decimals actually. I'm going to just leave it as a simplified radical though. All right, I know that is a long process, so let's refresh. To complete the square, you move the constant out of the way and add in a new constant. By taking the b value, cutting it in half and squaring it, that gives you the new number you need to add in. Don't forget though to add it to both sides to keep it balanced. At that point, you really just factor and you're done. Once you've got it factored, it should be something squared that you can do the square root method on and solve for x. Something that you might get asked on a multiple choice kind of test would be like, what should you fill in the blank here to complete the square? And you would need to know to like take that number, cut it in half, and square it. Let's do 2 more examples. This one's gonna get a little crazy with some fractions, but thought I'd at least show you one. All right, so on this one, notice the constant is actually already moved over to the other side. It's already out of the way. So that's great. We don't even have to do that step. I'm going to write out the same problem, just leaving a blank right here for the new number that I'm going to add in, because I know I'm going to do that. And don't forget to add it to the other side too. All right, remember the way I complete the square, the way I find that number to add in is I take this, the b value, cut it in half, and then square it. That is a fraction. -5 squared is 25, and 2 squared is 4. So the number I'm going to add in is 25/4. Don't forget to add it to this side too. That's okay that it's a fraction. I can do this. Now I'm going to factor. It's kind of tricky to do rainbow method with this. So on this one, you probably just want to use the shortcut. Like your factors are going to be whatever this is, cut in half. So -5 halves. And then this you can do in your calculator, that's fine. I'm just going to do it in my head real fast. So I'll turn this into fourths. So 6 times 4 over 4 would be 24/4 is the same as 6, plus 25/4, which is 49/4. So all this becomes 49/4. All right, we completed the square. We turned this into x plus or minus something squared. Now we're going to do square root method to get x by itself. So to get rid of squared, you square root. Don't forget plus minus. That cancels that, and we just have x minus 5 halves. Here's the reason I left it as a fraction rather than a decimal. This will square root evenly if you split it up. The square root of 49 comes out even, and the square root of 4 comes out even. That's just square root of 49 is 7, square root of 4 is 2, and it's actually just 7 halves. You could do that as a decimal as well, but I like the fraction version. All right, we're almost done. Let's just add 5 halves to both sides. So x equals plus or minus 7 halves plus 5 halves. Here's the thing, you got to be careful with this. This will simplify a little further. We can split up positive 7 halves and negative 7 halves. But you don't want to just add these and leave the plus or minus because it's going to come out different with the plus and the minus. You need to split it up, positive 7 halves and negative 7 halves. Whoops. And add the 5 halves separately. Because this comes out to be 12 halves. 7 plus 5 is 12, which is actually just 6. This one comes out to be negative 7 plus 5 is negative 2 over 2, which is negative 1. So they actually have very different answers. And they're even whole numbers. Imagine that. So those are my 2 answers. Remember, you can always plug in the answers and make sure they work. For example, does 6 squared minus 5 times 6 give you 6? Same thing with negative 1. You can check and see if it works. We have one final example here. And I apologize, this is a rather longer video. On this one, what's different about this one is you actually have a number in front. And you notice the other examples only had a 1 as a leading coefficient. This one has a 4. You want to get rid of that 4. You only want to have x squared up front. The easiest way to do that is just divide everything by 4. Because 0 divided by 4 is just 0. And as long as you do it to both sides, it's a legal move. So 4 over 4 cancels and leaves just x squared. 8 over 4 is 2x. 9 over 4, let's make that a decimal this time around. 9 over 4 would be 2.25. And there we go. So now I got rid of the leading coefficient, which is what I was trying to do. Now we'll do it as usual. Go ahead and move the constant over to the other side out of the way. So add 2.25 to both sides. And so you get x squared plus 2x plus some mystery number that we're going to find equals 2.25. Okay. So remember, to find the number that we're going to add in to complete the square, you take your b value, cut it in half, which is 1, and then square it. 1 squared is still just 1. So I'll add in a 1. Don't forget to also add 1 to this side, and then factor this. It's always going to be this number cut in half. So x plus 1 squared. But if you forgot, you can always do rainbow method. What multiplies to give you 1? What times what multiplies to give you 1 and adds to give you 2? And that would be 1 and 1, which is why I have x plus 1 squared. There's 2 of them. 2.25 plus 1 is 3.25. And then that's it. I completed the square, but let's go ahead and finish this up. So square root to get rid of the squared. So x plus 1 equals the square root of this. I probably should have left that as a fraction. 3.25 as a fraction is 13/4. Don't forget plus and minus as well. And we're almost done. Just subtract 1 from both sides, and that's pretty much it. So x equals plus or minus square root of 13/4 minus 1. Those don't combine because this one's a radical and that one's not. And you could put the -1 in front if you wanted, or in the back, either way. You can technically simplify this a little bit more. That's why I changed it back into a fraction, because 13 does not square root, but the 4 does. The square root of 4 is just plain old 2. So I'm going to simplify to that. That's my final answer. All right, that is completing the square.